Hello, good evening, and welcome to a very special question time edition of The Sky at Night. We're at the British Science Festival here at the University of East London. We've got a very wonderful live studio audience. We've got some very difficult out-of-this-world questions, but an interstellar panel of experts who are going to help try and answer them. Welcome to The Sky at Night. Hello, good evening. Thank you. Welcome to the Sky at Night. Welcome to our audience. Welcome to you at home. It's lovely to be here. It's great to be in East London. No stranger to astronomy, East London. Of course, we've got the Royal Observatory Greenwich just down the road, which actually next year, did you know this, is celebrating its 350th anniversary, I believe, which I think in kind of astronomical sense, it's kind of just getting warmed up. So happy birthday to them next year. Now, we like to do a show and tell. Whenever we do the Sky at Night question time, we like to bring an object that kind of relates to astronomy, but also where we are in location-wise. And so we were thinking about the Royal Observatory Greenwich, and they have the biggest refracting telescope in the UK. I think we might have a little picture of it here. And so we asked if we could borrow that. Unfortunately, there were some technical challenges getting it through the door. We begged and pleaded. They gave us this instead, which is not Britain's largest refracting telescope. Does anyone know what this is? It actually belonged to Edmund Halley, and he used it to determine meridians. Now, you've all heard of the Greenwich meridian. Chris, there he is. That is Edmund Halley himself with his fine head of hair.
Fine wig, yes. This thing he would have used to set up his own meridian. So a meridian is just a line that astronomers used to reference their measurements against.
Yeah.
So all the astronomers of the time had their own. If you go to Greenwich, there's not just the Greenwich meridian, there's a whole load of marks on the floor for Halley and the other astronomers royal.
Okay, so why do you need, what was the purpose of
So they were trying to map the sky,
Yeah.
and so you need a reference point to map against. And so you set up the telescope north-south, and then that's your meridian, and then you time things crossing and compare to other observations.
The other thing, of course, when we think of Halley and we think of telescopes, is we think of comets. Now, he didn't discover Halley's comets, even though, weirdly, there was a comet with his name on it. I don't know quite how that works. But Halley actually predicted that it was going to come back. So he predicted the kind of cyclical nature.
That's right. It's the first time somebody had said that this thing will reappear. It's not just an omen. It's a recurring phenomenon.
If you get your telescope and you look at the comet, at what point do you go, that's definitely going to come back?
Oh, you do a lot of maths. So this is sitting in a small room in Oxford with tables of numbers. So it's the other kind of astronomy, not to do with his telescope.
And the next Halley's comet is 2061?
That's about right.
It's also going to be, I worked it out, I did the maths just now, the 106th series of Sky at Night.
There you go. We'll still be here.
There we go. So anyway, so that is our wonderful bit of astronomy history for you, and a little bit of science history there. Now, as well as Halley being a wonderful astronomer, we have some wonderful scientists and astronomers on stage. So I think we should meet them all. First of all, we've got Maggie Adair-Pocock, or should I say Dame Maggie Adair-Pocock, because you were made a dame this year.
I was.
There is nothing like a dame.
I could do the dance. It comes with its own little dance, actually. So.
I remember last year they made a Barbie after you. Before that, they made a clanger after you. This year, you're a dame. They should just give you all the awards at once. They should just give you every accolade in one kind of wheelbarrow. And just, exactly, yeah. What, do you have to do anything as a dame, or do you just prance about, or how does it work?
I don't know. I think it's made me feel guilty, because you think, why did I get that? Oh, my goodness.
You're brilliant.
What have I got to do?
You've got it, because you're brilliant.
Oh, thank you.
So we have Maggie, who you all know. Chris Lintott, who you all know as well. Actually, you got an award this year, which I liked. You got, well, I don't know if it was an award, but the Daily Star called you a boffin officially.
Yes.
It was in inverted commas.
But it's an important moment for any scientist, I think, to be boffined by the Daily Star. And in my case, In my case, it was because they claimed that I'd said that there were definitely tiny little cows on Mars.
They weren't tiny cows, they were just far away cows.
They were both. They'd have to be small. We'd have seen them by now. But there's methane on Mars that we don't understand. And I got into an argument with an eminent planetary scientist on the radio about whether it could at least theoretically be tiny cows.
Okay.
And we decided that we couldn't rule out the possibility of tiny cows on Mars. That went into the Daily Star as top boffin says tiny cows on Mars exist.
Top boffin. Now, we don't have Pete Lawrence here. Pete Lawrence, our regular stargazer, is not here this year. But instead, we've got George Dransfield, who's another Sky at Night presenter. And again, you've won an award this year. You are now officially a doctor.
Yep.
You finished your PhD.
I did.
You got the prize for the best thesis of all time ever in all of science.
Or something.
There was something attached to it.
It was the best astronomy and astrophysics thesis for last year, yes.
Well, that's the same thing.
Almost,
and you've come into this relatively late. You were a school teacher for how many years?
6.
6 years, and then you enough, I'm going to go to university and do my PhD.
No, actually, I mean, so a lot of people leave teaching because they can't bear to teach anymore, I guess. But I actually, I left because I loved teaching so much and I loved my kids so much. But they were so awesome and inspiring and I just got jealous of them. And they just kept going off to uni and doing new cool things. And I figured I wanted to do the same. So I quit teaching to go and be a student again.
Nice. And here you are.
Yeah.
Well, congratulations. To your left, we have Raman Prinja, the head of physics and astronomy at University College London. Okay, your prize that you've got recently is my favourite. So the American Institute of Physics.
Yeah.
You know, like American universities, they would say you sort of get given a chair, and that's a sort of phrase. I didn't realise they actually gave you a chair, like a proper chair to sit on chair. But this,
yeah, I didn't realise it myself. I thought there was going to be some kind of commemorative item, maybe to put on my desk. Didn't I realise that it was going to be a real chair? I started to worry I needed to get my Allen key out and get my DIY skills ready for a flat pack about to turn up. But to my surprise, when the package arrived, it was a fully assembled, beautiful Windsor chair as a prize from the American.
And there it is. See, that's classy. That's a classy scientific institution that gives you one of those. Well, thank you, Raman. To my right, we've got Eloise Stevens, a computational astronomer from Oxford University, who won. Everyone's winning stuff this year. You won the Caroline Herschel Prize Lectureship. So just explain to us what that is.
Yeah, so briefly, so Caroline Herschel was the sister of William Herschel, which more people may have heard of, and she was also an astronomer, so the prize is to celebrate early career women in astronomy.
And also, when you got the news about this big prize, they called you up.
So they called me up. Usually, if you're expecting, to get an award or to get rejected from an award, as is more common, you'll get an email, but this time they called, and I was in the middle of attending a lecture by an eminent professor. And also, I was born in the 90s, so when I get a call from someone I don't recognize, I don't answer the phone. So I hung up. I hung up on the president of the Herschel Society, who had to text me to say, I am the president of the Herschel Society trying to contact you about the prize.
Well, listen, you're all welcome. Thank you very much. This is our panel, ladies and gentlemen. Great. Right. Okay, we've got lots and lots of questions to get through, so let's crack on. So we're going to start at the very beginning of the universe, with the very furthest and oldest of galaxies. We've got a question from Mel in West Sussex, who has shared a video with us.
The oldest galaxies are located at the outer edge of the known universe, but the light we see from them dates from soon after the Big Bang, 14 billion years or so ago, when they were much closer to the centre. Please can the panel explain how this apparent paradox occurs?
A simple question, but is it a simple answer, Eloise?
Yeah, so I think the simple answer is the apparent paradox arises because astronomers have been bad at explaining the expansion of the universe. Because there is no center to the universe. It didn't expand from one point.
Apart from here, maybe.
Apart from you, of course. Apart from you. So there's not one center to the universe, but there is a center to our observable universe, because the speed of light is finite, so it takes time for light to get to us, and there's only so far that we can see. That's what we mean when we talk about galaxies on the edges of the universe. We mean our observable universe. But these galaxies are still out there. If you could teleport there, right here, right now, they wouldn't look the way that they do now. They would have a vibrant life, different stars, different potential planets, maybe aliens looking out through their observable universe, looking at the Milky Way galaxy the way that it was 14 billion years ago.
Excellent. Okay. Sticking to the edges of our universe, if you like. This one comes from Fred Beaumont, who watched a recent Sky at Night episode all about the James Webb Space Telescope. And Fred asks, I saw amazing pictures of the furthest galaxies shown by the JWST, but I noticed smaller or fainter dots close to the furthest galaxy mentioned. Does that mean they were further away? Or smaller galaxies or clusters that may have been closer to us? Okay, so Fred's talking about, I think we've actually got the image up on screen. There we go. It doesn't look like a lot. Let's start with George. What's your thoughts on this?
So, I mean, honestly, any opportunity to talk about these images is so cool. So these are the deep field images taken by JWST, and every dot there is pretty much a galaxy or star cluster outside of our galaxy, obviously. The one thing I would say about the question is that fainter and smaller doesn't necessarily mean further away when we're looking at these, because it really depends on the composition of what is in those clusters or those galaxies. So the reason we know that this furthest galaxy is so far away is because they did additional observations, and they took a spectrum which allowed us to measure the cosmological redshift and see how far away it is. So in order to know every single dot and know if those are further or closer, we'd have to do the same
so we don't know. But Roman, you're an expert on aging stars and galaxies. How on earth do you look at a star or galaxy and work out how old it is?
Well, the ages of stars is a difficult exercise, actually. It's very hard to measure the age of an individual star because stars change over millions and billions of years, as you can't study one star. So it's a bit like if an alien was to visit a town and you gave the alien 24 hours to figure out the life cycle of a human being. There's no point in them watching one person. Usually doesn't change much over 24 hours, unless you happen to be on this panel, maybe we might change a bit. But otherwise, what you could do, what the alien can do, is go to a hospital, see some babies being born, a primary school maybe, see some secondary school children, adults, maybe even someone passing away. And then you could go away and the alien from that information in one day visit could work out that that is the life cycle of a human being. Same thing we can do with astronomers or astro detectives. We use a snapshot of stars, groups of stars, and we can try to age them from that.
Thank you very much. We've got a question again about the very old universe from a very young viewer. I'm not sure how young. I think he's 9. Harris Brooks from Cheshire.
I'd be very interested to understand how much light is emitted from JGS Z14. The recent discovery of the earliest observable galaxy by the James Webb Space Telescope. Is the amount of light detected by the telescope comparable to seeing a candle on the moon?
So Des, just to say quickly, he appears 9 because that's when the light left him, but he's now 16.
That's cleared up. It's a good question. So how much light are we getting? Eloise, you've done the maths about this, haven't we?
So we're not getting a lot of light. You can see how fuzzy that is, and that is with one of the most powerful telescopes, the most powerful telescope that we have today. That's 28 magnitudes, if that means anything to you. And if it doesn't, it's like looking at a light bulb, a standard light bulb, 20 times further away than the moon, or 3 times further away than JWST.
Wow.
Yeah.
It's amazing that we can even see such faint light. So, Baggy, how is that possible?
So it's challenging, but it's the way we design the telescopes. So we have big mirrors because we want to gather as much light as possible. And then we sort of process that light. And this image here is something called the micro-shutter array. One of the things we can do with the James Webb Space Telescope is not just look at one object at a time and not just take a photograph, but take the spectra, which is taking the light from the object and stretching it into its rainbow colours and analysing that light. And so what we can do that with the micro-shutter array, and you can see this is there's a human hair in the centre of that
where's
image
the
at the
human
top.
hair?
You can see there's sort of something curving in the centre of the screen.
Yeah.
That is a human hair. So these micro-shutter windows are sort of the order of a human hair. And so you have thousands of them, I think 250,000 of them, and you can open and close whichever ones you want. And so when you get a star field like that, you can open this window, and get the spectra of each of those objects in those windows and analyse the light that way. So it could be a tiny bit of light, but we're taking their spectra.
Yeah, this is pretty stunning technology. With JWST, we're talking about something that's tuned to the infrared to pick up very faint heat sources. So another example of the power of this is it's said that if you had a hardy bumblebee on the moon, JWST could detect the heat from that bumblebee.
A bumblebee on the moon.
It needs to be
pretty hardy bumblebee.
Yes. Spacesuit bumblebee.
You know, they mocked me for cows on Mars.
Yes. Bumblebee. The next boffin, right here.
Yes, the fact we can do this. And it is, yes, there's heat energy, which gives us a new view of the universe. We have had infrared telescopes before, but because of the size of that mirror, we're gathering so much light.
OK, while we're on the subject of technology, we have a question about another piece of kit that is looking back into the distant past. And this one is from Brian Walker, who's in the audience. What's your question, Brian?
Over 10 years ago, I attended a talk about the Australian Square Kilometre Array Pathfinder, ASCAP. The impression I got from ASCAP was paradoxically too effective at gathering data. It could collect a staggering 1 exabyte of raw data per day. The speaker explained that the technology to store such vast amounts of data didn't exist yet. I'm curious, has technology finally caught up since then?
Wow, that's interesting. So basically, with too much science is being produced for the amount of data storage we have. Actually, Ramin, can you start with this ASCAP? What do we mean by ASCAP, just for those who are not familiar, like me?
So ASCAP is a very powerful facility for detecting faint radio signals from stars and distant galaxies that's located in Western Australia. You can see one of the dishes from ASCAP. What's really special here with ASCAP is they have 36 of those dishes. Each one of them is about 12 meters in diameter. And the cool trick is then to try and combine, and they do successfully combine the signal from all of them in various arrays and configurations. That requires transmitting lots of data.
Yeah.
But then you create a very powerful facility for detecting these radio waves.
So basically, there's this kind of a lag between the amount of data, a bit like my email box, like just mass emails all the time, and I just don't have the brain to process it.
Supercomputers help with your email and with radio astronomy. So this is part of a project called the Square Kilometre Array, which is building, this is the start of an array in Western Australia, but there's one in Southern Africa as well. So the equivalent of ASCAP there is called Meerkat.
Meerkat. Do you compare them?
Yes, that's right. Very good.
Sorry, that was a terrible trick.
But Meerkat's producing wonderful results as well. So this is a radio image. So we're getting so much data from these telescopes that we can now create not just data sets, but images with radio astronomy. And this is the center of our galaxy in radio waves. And you can see it's a really complex place. The black hole at the center is in the middle of that bright blob in the middle. But there are all these strange streamers and bubbles and so on. And what this means, we don't know, because we've only just seen this image. And it's an incredibly complex thing. But creating images like this saves you some of the data, because we can take the raw data, create an image, and then throw away the raw data, but it doesn't solve this problem of having more data than we can possibly look at.
So what's the answer? Do we just build bigger storage clouds?
The trouble is that becomes very expensive and difficult. So an exabyte, if you think of it in volume, if a gigabyte was the size of the Earth, an exabyte is the size of the sun.
Yeah.
So it's that sort of ratio. So it's very difficult to store these things. What we have to do is get cleverer at using
this is what I was going to ask Eloise, as a computational astronomer, can we use AI now, or the new technologies, in order to be able to process this enormous amount of data?
That's a very good question. And there's two sides to this coin. On the one hand, machine learning can help. On the other side, there's still a lot of 70s technology that you have to rely on.
That's kind of, I love that.
Who loves a good SQL and relational database? So I'm part of a sky survey. There's optical, not radio. It's the Atlas Sky Survey. And this survey can observe the whole night sky every 1 to 2 nights. And its job is to track solar system objects, but also to find extragalactic transits, explosions.
Yeah.
So what it does is it takes a snapshot of the sky and then compare the Meerkat, to a previous observation. And if something has changed, it's like a game of 7 differences, except it's 10 million differences every night, and you have to process that every single day.
Yeah.
To do that, you need to transfer data from Hawaii to Belfast. You have some machine learning that finds all of the, or as many as possible, bogus alerts.
Maybe we should just stop all science now. Get the internet working.
Get the internet working.
Get your printers working. Get those sorted out. Can I just, why is all this data important? Do we need it all?
Absolutely. I know that in some areas of astronomy, there is this practice of kind of selecting the data that's useful and keeping the processed data and getting rid of the raw data. And I mean, this is heartbreaking because we are still finding fabulous results from really, really old data. So honestly, all raw data should be stored forever. And ever. Yeah, we just need to get better at storing it. And we need to make sure that, like, when we're kind of proposing for time on telescopes, we actually have a good plan in mind for how we're going to store for posterity all of that amazing data.
I'm going to move on just for time. Right, we're going to stay on Earth with some questions a little bit closer to home. Well, some 250 miles above us, in fact. And we've got a wonderful question from Tez Greenwood in Sheffield, who wants to know about time in space. He asks, I've always wondered how astronauts on the International Space Station adapt to replicate the structure of a 24-hour day living on the Earth's surface. Do they follow an Earth time clock? For instance, hypothetically in the long term, would they follow Earth time to structure their daily activities and schedules if they were living on Mars, for example? So Maggie, first of all, let's start with the International Space Station. What time zone is the ISS?
So it travels round the Earth every 90 minutes. It's sort of in low Earth orbit, let's say 350 kilometres above sea level, which means you get a sunrise and a sunset every 90 minutes. And so as timescales go, that's not a good one to go for. So what they've done instead is they've actually set it as UTC, which is a universal time, but it's a coordinated universal time.
It's basically Greenwich Mean Time.
It is.
Because here we are
yes,
in East London.
It's very appropriate.
Yeah.
But they went for that because it is sort of halfway between the US and Russia. And so half a day's shift is done by the US and half a day's shift is done by Russia. And so that's what they've gone for. So it's a 24-hour cycle, but set on effectively Greenwich Mean Time.
Got it. Actually, George, you were in Antarctica during the summertime, so basically daylight all the time, which is actually similar, I suppose, to how it must be working on the space station.
Yeah. And actually, one of the really cool things about where I was is that they often send people who are going to maybe be astronauts to so that they can do some science and figure out how people cope with not having a proper day-night cycle. So that picture's actually me at midnight on New Year's Eve in Antarctica, and it's like minus 45 degrees.
I was going to ask, I mean, underdressed? I don't want to...
A little bit. But to answer the question, definitely not having the kind of the sun behaving properly really, really messes with your circadian rhythm. And those attempts to maybe just ignore the clock entirely really mess with your ability to work with other people.
Actually, I've just had a thought. I mean, we were talking about candles and bumblebees on the moon. As our resident bumblebee moon expert, Ramin, what time is it on the moon?
Very good question.
Such a thing exist?
No one's really sure what the time is on the moon right now.
Can we just arbitrarily decide it's 4 o'clock?
There's certainly a need to decide something because we need some kind of coordination. We need this. There's a move now from the space agencies to try and establish a single time zone for the moon. Because if you're looking at, for example, exploring the moon and building bases on the moon, we've got to sort out coordinated communication and mapping and surveys. So we need a time zone.
May I suggest Greenwich Mean Time?
Just putting it out.
Just throwing that out there.
But we are going to have a problem when we get to Mars.
Well,
because if you're living on Mars, it has a 24.5-hour day. So you'll want a solution that coincides with the sun, but you've got this extra half hour compared to what we're used to. So the solution, I think, is from the science fiction writer Kim Stanley Robinson. So in his Mars trilogy, what he does is that if you live on Mars, you have a time slip. So you have a 24-hour clock, and then the clock just stops for half an hour every day.
That's awesome.
And that's half an hour where you can't plan to do anything, you can't be in a meeting, you can't arrange to go anywhere. It's just time that just is given back to you.
It just sort of stops and you can do whatever you want.
And the nice thing is that because it would be at a different time of the day at different points around the planet, you can choose where you want to be. So if you're a party animal, you can have your extra half an hour at 11 o'clock at night. If you like work, you could be there at 10 and have an extra half an hour to get your emails done. It's a great system.
We'll move on. Thank you very much. That was a great question. Thank you very much. We'll move on. Actually, another International Space Station question. This has been in the news recently. And great, someone in our audience. Milo Sumner, you've got an International Space Station question. What is it?
My question's about the recent issues with the Boeing Starliner that led to a couple of astronauts being effectively stranded on the ISS. Should this incident lead us to be reconsidering the role that commercial companies play in space exploration?
So this is, I don't know if you all heard that. So questions relating to this Boeing Starliner, which is this new ferry that takes astronauts up to the International Space Station. It had a problem with its thrusters, which meant it returned without astronauts just to be on the safe side. And so these two astronauts are having a very lengthy stay in space rather than their 8-day stay. The question is, I think companies like Boeing have always built spacecraft. This isn't a new thing. NASA, for example, the organization, do not build rockets. They get companies to build rockets for them. And companies like Boeing and Lockheed Martin and Northrop Grumman, Boeing, for example, built the first stage of the Saturn V. So this is not a new thing. I suppose the question is more aimed towards sort of newer companies who are less familiar or we're less familiar with. What do you think?
I think the question is about space becoming more of a free market. So when you have NASA subcontracting to specific companies, they keep a strong hand on what those companies deliver. But if some companies try to get onto that market and they have, core values and bottom lines like make profit because shareholders need dividends, these values don't necessarily align with the amount of precaution that you need to observe when you're sending people to space. Even if you have lovely people working as CEOs and on those boards, at the end of the day, that system has pressures that are not aligned with that of engineering and science.
So are you suggesting there needs to be sort of tighter regulation or more
that the people that make final decisions and that decide of the strategy are not held accountable by shareholders trying to maximize profits.
But it's definitely true that some of these companies can think differently about risk. There was the recent first private spacewalk, which was a private mission using, the Dragon capsule that was paid for and developed for a NASA contract to go to the space station, but being used for a fun joyride out to outer Earth orbit and an impressive spacewalk. But the way that was done with untested spacesuits and where you open the hatch in a way that hasn't been done since the 60s, NASA wouldn't necessarily have taken that risk. So companies are able to do different things. I think the problem is really that when we give somebody permission to launch something or somebody into space, there's no agency that says, what are you going to do with that? You're not allowed a weapon. But apart from that, there's nothing that says, we say, will your rocket blow up? Is it safe for other satellites? Then sure, SpaceX or whoever else, go launch another 200 satellites, no problem. What we don't do is say, look, we've got a limited bandwidth in low Earth orbit. We can't have all the satellites that everyone would want to launch. They get in each other's way. There is enough bandwidth in the radio spectrum for them all to talk to the ground. But we don't say, are you doing anything useful? Are you doing this safely? And I think we do need regulation.
But doesn't that then get us into all kinds of political questions, like who makes the decision?
But you're making a political question if you just say anyone can do anything.
Well, there is space regulation out there already. And the thing is, it's just very, very dated. And so there is sort of treaties and things like that setting out what you can and can't do in space. You mentioned sort of not using weapons. But the problem is it hasn't kept up with the times. And I think people are working on it, sort of space lawyers, which it sounds like a great title. But there are space lawyers doing just that.
We're going to move on. Basically, it's complicated. is the answer to your question. We're going to move on. We've got a question about the solar system. Again, from someone in our audience. We've got Sophie Green. Where's Sophie? Hi, Sophie.
We know that in about 5 billion years' time, the sun will expand and will engulf Mercury, Venus, and possibly Earth as well. That will be the end of those worlds. But what about the other planets? Between the expansion of the sun and the end of the universe, what will happen to them? Will they float around aimlessly or degrade in some way? And if they will float around, could there be exoplanets out there floating away from a dead parent star?
Crikey, wow, what a question. Thank you very much. So the sun is going to expand and engulf the inner planets. What's going to happen to all the other planets that don't get engulfed? Raman, as our expert, I don't know, give us the worst case scenario. So just build on what Sophie said. The sun expands and then what?
I mean, we've got about 5 billion years from now, I guess. That's
okay, we're okay for
time.
Yeah.
It's okay. Calm down, everyone. It'll be okay. In about 5 billion years, the sun will essentially run out of its nuclear fusion source of energy, and it will start to change drastically, as we've just heard. So the sun will start to expand into this red giant star, enormous radius. Yes, Mercury's a goner. Venus will be swallowed up. Earth might just about survive because the orbits of the planets in the solar system might move out slightly because the sun's mass will be slightly lower. That will just change the orbit slightly. But the worst scenario, we're talking about boiled off oceans, the atmosphere is burnt. I think we need to be leaving this planet about 2 billion years before that, actually.
So we need to get off quick. George, what do you think?
So, I mean, we have actually from the exoplanets field some information now about like whether or not planets can actually survive the evolution of their host star. And we have this because we have found planets around white dwarfs. So recently we found some, Jupiter-sized planets orbiting white dwarfs and kind of, still intact. And we've also found planets that haven't quite survived by finding the pollution of dead planet pieces in the atmospheres of white dwarfs. So you can see in this image a planet just being destroyed as it falls into its white dwarf host star. So, potentially some planets will survive the full evolution of the star, and potentially they won't.
There are some rogue planets, aren't there? There are correct me if I'm wrong, there are planets just floating about.
Yes, this is an artist's impression, but we know because we see the effect of their gravity on distant stars. We know there are billions of these things out amongst the stars of the Milky Way. There may even be as many planets between the stars as there are around them. And some of those, you're right, will have been let go by their stars when the stars reach these later stages of their life. So some of them may escape early, and then others will be the remnants of long dead systems. And so these planets will still be floating amongst the stars. They're cold, they're presumably dead worlds, unless people have invented some very impressive technology to live on them. But yeah, so these rogue planets are out there, and there's something melancholy about them, I think.
That's the ultimate off-grid, isn't it?
It is, yes.
I want to go off-grid. Yes. I'm going to find a rogue planet. We're going to move on. We've got a video question, I think. Again, so when our sun inevitably engulfs the Earth, continuing a theme, evicting humanity, we are going to need somewhere new to live, which leads us on to our search for habitable planets. Bob Whedon from Horsham has a question. He sent it on video.
There have been several reports lately of potentially habitable planets circling red dwarfs. As such planets would orbit much closer to their star than the Earth, and we cannot look at the sun without damaging our eyes, would living on a planet with such a large part of the sky filled by its star ever be practical?
That's an interesting question. Raman, I'm going to come to you on this as our star evolution expert. So first of all, red dwarf, what do we mean by red dwarf?
These are, as the name suggests, very small stars. So maybe about the 10th of the size of the sun in terms of radius, and also not very massive at all. Again, maybe around about a 10th of the mass of the sun. Now, what's really important is that the life of a star, the clock, if you like, how fast it changes depends on mass. Because the mass of a red dwarf is so low, they have enormous lifetimes. So they could have lifetimes of tens of billions of years, greater lifetime than the age of the universe. They will be the last stars standing in the universe. When the lights of the universe finally go out and the starlight finally goes out, it will be the light of red dwarfs. And these stars are important because they're so populous in our galaxy. Perhaps 100 billion red dwarfs in our galaxy, and perhaps a very large fraction of them have planets.
They'll be the last things. The Sky at Night will still be going, though. And that's the important
thing.
They're reporting. George, you think about exoplanets. Why are they exciting? What would it be like to stand on one? What would a red dwarf in the sky look like?
It looks so cool.
Would it look like this picture? I always worry about these pictures. And did these pictures make you cross because they're not real?
So we need the artist's impressions to kind of like have any way of visualizing it, because otherwise we just look at graphs all day long, don't we? So we've actually got really good at detecting planets around red dwarfs. And we actually think that for red dwarfs, planets is the norm. So we think that most of them do actually host multiple planets, which is really, really exciting because they're super easy to find. Now, in terms of habitability, yes, it's easy to find planets in that kind of, famous habitable zone, the Goldilocks zone around a red dwarf star. And as mentioned in the question, they are much more compact. So they are much, much closer to their star. So this here actually is a really cool image showing the TRAPPIST-1 system. And so this is a red dwarf star about 10% the size of the sun. The star is roughly the size of Jupiter, and it has these 7 terrestrial type planets orbiting it. And you can see actually that the entire system would fit inside the orbit of Mercury. So crucially, yes, we are much closer there to the star, but the star is a lot smaller. So it would probably look a similar size in the sky to what the sun does on Earth.
Okay, that's interesting. Right, okay, we're going to move on. More about exoplanets, actually. The idea, of course, is discovering Earth-size exoplanets, which has been sort of difficult up to now. And leads us into 2 questions, really. So the first question from Chris Flatt, who asks, how soon do you think technology will be good enough to detect Earth-size planets around other stars? And then that leads into this question from Jennifer Lewington. Do you think it'll be possible for humanity to eventually leave Earth and the solar system and actually go there and inhabit and populate, thrive on another suitable exoplanet in the galaxy? This is kind of far off in the future. George, what do you think?
Well, finding Earth is actually something that we have been able to do. So we found many planets very similar in size to Earth.
Yeah.
But the big prize, what we haven't got yet, is an Earth-sized planet around a sun-like star in an Earth-like orbit.
So detecting exoplanets, there was always the big planets you could see because they would make the star wobble a little bit.
Yeah.
And then we had the transit method where you have that dipping of light.
Yeah.
So what do we do to look for them?
Well, so neither of them would work with the current instrumentation. However, looking a little bit into the future, in 2026, ESA, the European Space Agency, is launching a new satellite, Plato, and Plato's main gig is going to be searching for Earth-like planets around Sun-like stars in Earth-like orbits. So, you know, after it's been observing for maybe 2 or 3 years, maybe we will have some.
So when we find an Earth-like planet like that, will we have the technology to be able to look at the spectra and be able to see the chemicals in the atmosphere, which would give us telltale signals of life?
Not immediately. For that, we will need another instrument further in the future.
Okay.
Yeah, so we'll need to actually look at the spectroscopy, but for that we need much bigger light collecting surface than Plato's going to have.
We'll get the printers working
Yeah,
first.
we're planning this. So this is the Habitable Worlds Observatory, which will be a big international project in, maybe as soon as the 2040s, if you want to look forward to it. But this will be, it may well look like this, who knows? But it's a telescope with nominally something like an 8-meter mirror, so as big as the biggest telescopes we have today, yeeted into space. And then we get to measure the atmosphere of these planets. And then we could tell you that there is, hopefully, an Earth-like planet around a Sun-like star in an Earth-like orbit with an Earth-like atmosphere. And then we're very close to saying that there might be life.
Maggie, if we wanted to get to one of these planets, as our resident astronauts...
In waiting.
In waiting. Yes. It's going to happen. Next year, you know, Clanger, Barbie, Dame, astronauts. That's how it works. I mean, could you... Obviously, these planets are a long way away. Could you envisage a time where we could actually travel these great distances?
So, as has been said, we need to sort of find the planet, right orbit, it's got an atmosphere, let's go.
Yeah.
But the challenge is just travelling from our solar system around the sun to the next door neighbour solar system around Proxima Centauri. That is 40 trillion kilometres. That journey would take 76,000 years. It's a bit of a pain. But there are ideas out there. One was by a Mexican mathematician called Alcubierre. And there's another premise that you can't travel faster than the speed of light.
Yeah.
And so when we're travelling these vast distances, it becomes challenging. And so what he suggested is you don't travel faster than the speed of light, but what you do is you warp space and time in front of you, elongate it behind you, and therefore you don't travel. You haven't you haven't travelled faster than the speed of light. But because you've warped space and time, you can get to your destination.
That's how I got here today. The Elizabeth line's a lot like that.
I was wondering why you were
kind of like bends space.
I just want to say, you can tell he's a mathematician because he's got as far as, so what you do is warp space and time. He's like, I have solved all the important bits of the problem. The engineers can do the rest from here.
Over to you guys.
There's that big sort of in brackets, like magic happens here.
That's right.
As can be easily demonstrated.
Okay, we're going to move on. Whatever the future holds in space, hopefully it holds a good future for all of humanity and a sustainable future as well. We've got a question from James Watt. There's a good scientific name for you. James Watt, who's in our audience. James.
How can we best use space to promote unity in a troubled world? Thinking of the Apollo-Soyuz missions of the 70s, for example.
Yes. It's a very good question. How can we use space in a troubled world? First of all, Apollo-Soyuz, this was a mission in the mid-70s. So after the Apollo moon missions, they took the Apollo capsule and the Soyuz capsule, which was a Russian capsule, and they built a connector and they docked it. And here you have, I think it's Alexei Leonov, who's the Russian cosmonaut, who in fact did the very first spacewalk in 1965.
Yes, I met him.
And next to him is Deke Slayton, who's one of the Apollo astronauts. And we had that great moment of the two superpowers, the great space race. Finally, we were friends and all was wonderful. And so it was a great sort of coming together, a moment of that. I don't know, what do you think? I mean, the International Space Station is still that, isn't it? It's lots of countries and nations working together. It's still going above kind of earthly politics. The International Space Station still happens. Raman, what do you think?
I think for me, I mean, that image you just showed us is an example of that cooperation, that international cooperation that you're seeing there. It's the sort of platform for improving ourselves to some extent. You know, from that cooperation, from working together in that way, we can go out there and we can explore and discover and learn things, and we can spread that knowledge, and we can inspire the next generation of universe hunters and your next generation of Sky at Night presenters, and that's, I think, very positive. I think there's something to be gained, and we would improve ourselves from that cooperation. I think it's fantastic.
Space does, I mean, all these big missions now, no one's really talking about them doing them on our own. It always seems to be joint international missions. So, I mean, that's got to be a good thing, George.
Yeah, so I think
you're looking.
So I think
I'm hearing doubt in your voice.
Yeah, I think that space maybe could have the power to unify us, but I think actually it can still be incredibly divisive, because when we talk about things like missions to space and building huge telescopes, things that cost millions and maybe even going into the trillions of dollars, there are still so many people on Earth who have so little, and so it ends up really dividing us between the have and the have-nots. Right? You've got the people who have access to the science, access to space, and even worse when it's becoming a billionaire's playground, going up there just for the fun of it. And if you think of there being people on Earth whose lives could be changed for the sake of £100, it's never going to be something that is for all. And I think what we have to remember is that science is always political.
Yep.
So when people don't have access to science, then it's divisive.
So as a space scientist, I've worked on the James Webb Space Telescope. I've worked on sort of massive ground-based telescopes, looking out into space, understanding the universe, which is lovely and brilliant. But most of the work I've done has definitely been Earth observation. All these satellites which are trying to understand our planet better. And I think there is a fear that there are sort of the developing world are sort of running away with space and taking advantage of it and leaving other people behind. And that terrifies me. But at the same time, we can use space to do so much good. And so I'm in two minds. But I think I go out and speak to lots of school kids, and one of the things I say is, we've made a bit of a mess on planet Earth.
Yeah.
Let's learn the lessons here before we go further out. And so I think we need to make sure that space truly is for everyone. Everybody benefits from space. And then I get the opportunity to go out there again.
Great.
I have to get it out there. I'm sorry.
Thank you very much. It was a great question, actually. And Apollo-Soyuz is one of those missions we don't really sort of talk about much anymore, but it was very interesting. So thank you very much for your question. We started off the show talking about the earliest galaxies. We've travelled throughout the solar system. We've peered into our future a little bit, but we're going to take a little breather in the here and now. Although Pete can't be with us today, he has sent us a video to let us know what we can look forward to in the night sky in the near future. So over to Pete.
Hi everyone, I'm sorry I can't be there for this year's question time. Remember, if things get tough, just introduce infinite planes. They'll get you out of any trouble. But back in the real world, even though I can't be there, I wanted to give you a heads up about some of the things which are happening in the night sky. The back end of 2024 looks really interesting, with some rather unique events queuing up. Let's start with a biggie, something which is right up Chris's street, the potential for a naked eye comet. Now, as this programme goes to air, many will be anxiously looking into the evening sky to see what may or may not appear. Comet C2023A3 Sushishan Atlas passes through perihelion when it's closest to the Sun on the 27th of September. Coming in from the Oort cloud at the edge of the solar system, what will happen to the comet when it passes just 58.6 million kilometres from the Sun remains to be seen, but the predictions are that it will emerge from the Sun's glare, probably visible around the 12th of October, and be a naked eye evening object. The comet should be visible low above the western horizon following sunset during the middle of October. How bright will it get? Well, that's the big question. But it's hoped that it will be an easy naked-eye spot, and one which has a decent dust tail. Remaining in the solar system, the planets put on a rather poor show at the start of 2024, something which wasn't really missed because the weather was so bad. However, fingers will be well and truly crossed for the back half of the year, because the planets are putting on a real show. There's a lunar occultation of Mars, where the moon appears to move in front of the planet. This takes place on the 18th of December, but there's a catch, there always is, in that the event occurs under daylight skies. However, Mars will be bright enough to be seen in daylight through a small telescope, and the large 89% lit waning gibbous moon will be easy to locate. The event starts at 9:25 AM, Mars disappearing behind the moon's bright western edge. The planet reappears around 10:15 AM, this time from behind the dark eastern edge. Observe a little earlier than the stated times, because the moon is close enough to exhibit parallax and will shift depending where you live, in position relative to the more distant Mars, thus affecting the timings slightly. And as ever, take extra care using a telescope in daylight.
Saturn's coming back into view too, which is really good news because it's heading towards a ring plane crossing which occurs in March 2025.
If you want to try and catch Saturn, you can find the planet due south about 1/3 the way up the sky at 22:30 BST in mid-October. It reaches its position 4 minutes earlier for each day that passes, so that's 1 hour earlier every 15 days. Saturn's largest moon, Titan, will start creating shadow transits at the beginning of November, and these occur roughly every 16 days. Titan itself will transit Saturn early in 2025, but many of these events are timed badly, so do try and catch the shadow transits this year if you can.
So I hope you have a wonderful evening, cloud-free skies, and a comet to remember.
Chris, you're not a comet fan.
Well, I don't want to say this in front of Halley's telescope, but P and I have had, not rows, but a 15-year debate over this. He always says there's going to be a naked eye comet, and I go out and look, and it's a faint, fuzzy thing. I need comets to be spectacular. Big tail, as in the history books.
Exactly.
And they don't come around often enough. So
I want one of those Bayer tapestry comets.
That's right,
You know, like
exactly.
a proper, with a fire. And
we haven't really had one of those in the Northern Hemisphere for more than 20 years now.
Yeah.
So maybe this one will be great, but
Okay.
be prepared to be disappointed.
Okay. Well, we've still got Pete. Because Pete's away and not here, he has earned the privilege of being able to ask a question. So we've got Pete asking a question as well.
What astronomical sight has, if ever, changed the way you visualise the universe? As an example, many moons ago, I was able to catch an asteroid, 2012 DA14, through binoculars. And it changed the way I visualise astronomy because I was able to see it moving against the background star field in real time. And I realised that I'd never seen anything outside of the Earth's atmosphere moving in real time before, and that has always stuck with me.
Okay, George.
So for me, it was the moon. And embarrassingly, for a professional astronomer, the first time I saw the moon through a telescope with my own eyes was in 2021. I was on holiday in Yorkshire and I saw it through this telescope I'd borrowed from the university, and it seemed so big and I could see the features, and I got so giddy, and I just went over to people staying in the other cottages and was saying, "We can see the moon. Do you want to come and look at the moon?"
Did they call the police?
Only a couple of them came, and they were like, "It's the moon. You can see the moon." That is the photo I took. I took that with my phone through the telescope.
Yeah, it is really amazing. Chris, what's your sight that's changed your view of things?
This isn't going to help my reputation with the comet loving amongst you. It's a comet being destroyed. So there was a comet in 1994 called Schumacher-Levy 9 that got too close to Jupiter, and it was discovered on the way in. So there were a string of cometlets, little bits of comet, that over the course of a week hit Jupiter. And they hit on the far side, so we couldn't see it from Earth. But then later on, the evening after the first impact, I took my tiny telescope out into the back garden, looked at Jupiter, and I saw something that no one until that day had seen before, which was the bruise left by a comet impacting Jupiter. So this is the Hubble Space Telescope view of how those bruises evolved over weeks and months. But for me, it was the first time, a bit like Pete actually, realised that the universe could change, that it was a dynamic place. Yeah. And that excitement of seeing that through a telescope was the thing that pushed me into astronomy.
Eloise?
For me, it's seeing the night sky, seeing the proper night sky in a dark space, especially in the southern hemisphere. Because in the southern hemisphere, you can see the center of the galaxy. And when you're in a proper dark site, like an observatory, this was taken in Lucia in Chile a few months ago when I was there, you can see so many stars that all the constellations feel like they disappear. And although the picture is really pretty, it doesn't quite look like this with your eyes, but it was the first time in my life that I truly felt like I was on a planet hurtling through space, because you can see so many stars and feel the wind on your face, and it's dark and you're on your own, and you're like, I know I'm part of the universe, but I can feel it today.
Maggie, what did you have a moment of an epiphanal moment?
Well, actually, I'm very interested in archaeoastronomy. And so it's looking back at sort of every civilization has looked up at the night sky and wondered. And in the Northern Hemisphere, people came sort of with constellations, Orion, putting the stars together. But in the Southern Hemisphere, because you are looking into the heart of our galaxy, you see so many stars that they weren't looking at the stars, they were looking at the clouds of dust that lie in our galaxy, and they made constellations out of this. So this is a constellation called the Emu, and yes, see, with a bit of a Photoshop, this is what the constellation is based on. And so the Aboriginals were talking about these constellations, but based on the dust rather than the stars
that's
themselves.
Really interesting. I'd love it if it actually was an emu.
Turned around and squawked.
Rama, what's yours? Do you have a favourite moment?
Yeah, the thing that's thrown me off my Windsor chair. I think it has been the Hubble Deep Field, because when that first came out, imagine this. I mean, you're looking at a 5p coin, a patch of sky, a 5 pence coin sort of size, held about 25 meters away from your eye, and you're looking at a patch that would otherwise be empty if you'd use ground-based telescopes. You'd see nothing. And you point Hubble Space Telescope at this patch, co-add about 300 exposures of it, and you're seeing there almost 3,000 blobs, if you like, and they're all galaxies. Each one of those galaxies is loaded with billions of stars. And then when you think that you now try to map the rest of the sky with those 5 pensities, our cosmos is just incredible. And I mean, if that's not mind-blowing.
The other thing about this image is that many astronomers thought it was a pointless exercise because people predicted that Hubble would discover no new galaxies because they didn't realise the early universe would be more active than the local one.
Yeah.
And so these are not just galaxies, they're galaxies having the time of their lives. It's a firework display.
We're going to have to move on. We're sort of down to our last couple of questions, so we're going to have to move it along, so apologies. We're going to have a little question here about space exploration, which is interesting. It's kind of a Maggie question, I think. Let's explore Titan together. Glyn Birchall from Ipswich wants to know, technically, does the severe cold on Titan make it currently impossible to explore, or do we have the technology to deploy devices like airships, rovers, possibly even a boat that could survive and operate for weeks? So first of all, just tell us a little bit where Titan is, and can we explore it?
Yes. So Titan is one of the moons of Saturn.
Yeah.
And in terms of exploration, we've actually sent a probe called Huygens that actually landed on this moon. So the exploration has begun. And this is an artist's impression of the probe Huygens actually on the surface of Titan. So we have actually been there, and Titan is a fascinating place.
Why is it fascinating? What would be the reason to go there particularly?
So moons have had a renaissance. In the past, when we were sort of looking for potential life in our solar system, we looked at planets in the habitable zone, the right distance from the sun and things like that. But now we're looking at moons because they could potentially have life as well. So some of the moons around these sort of large planets, because as they orbit, they're sort of distorted and warped, they could generate energy, and so potentially something could live on this. We don't think there's anything likely on Titan because of the extreme cold, but yes, there is potential in the future. But we want to send, so on Mars we had Ingenuity, of the first helicopter on another planet, and we're expecting to do the same with Titan. This is something called Dragonfly. This is a mission that we want to send to Titan to fly over the surface and investigate that amazing atmosphere, the fact that there are sort of lakes of liquid methane, rivers, all sorts of things on the surface of this moon, and so we want to find out more by sending Dragonfly there.
Do we have a sort of time frame for this?
Launch 2027 or 28, so this is soon. This is an amazing mission, and you have to think Titan's a place where we've been to one place and we took one photo with the Huygens probe. There's a whole world to be discovered. It's going to be very exciting.
Right, finally, for our last question, we've got a little bit of fun, which I'm sure our audience and Sky at Night viewers are going to appreciate. Have a little look at this. This is a question from Chris Langfield, who's got a little bit of a moan.
I find myself complaining at the screen every time I see a TV show or a movie which depicts the moon filling half the sky, rather than being more like the width of the thumb at arm's length. What misrepresentation of astronomical phenomena really grinds your gears?
Well, we could do a whole series of just space gripes. Let's start with Raman. What makes you cross when you're watching science fiction films?
I've got a problem with Star Wars.
Star Wars, OK, let's have a little... We've got a little clip.
3,720 to 1. Never tell me the odds.
Everyone, you can't have a problem with Star Wars, surely.
I love the films, but that what you're seeing there is dodging through asteroid belts.
Yeah.
You have to, this dynamic maneuvering that you have to do. We all have to tilt around. And actually, the reality is asteroid belts are very, very roomy. I mean, typically you'd expect kilometers between these boulders of rock.
So that idea that they're all packed together.
The idea that you have this ace pilot that's trying to dodge through them is just always crazy. You
Just
don't need to be
through,
that
no
skilled.
Unrealistic asteroid belt. George, what's your bugbear?
It seems to be really easy in sci-fi movies to find planets that are so similar to Earth that you can just like ding something and it says, oh yeah, breathable atmosphere, and you can take off your helmet and the air is so earthy. And also, the gravity seems to be exactly Earth-like because
they've got budget restrictions, so they have to
step off and they can just walk normally. Like even a 10% change in the gravity would mean that you're just falling over. You don't know how to walk. It's just there's so much diversity of planets out there. You're not going to just constantly happen upon planets that are so like Earth that you have to make no adaptations. It's wrong.
Eloise, what's your issue?
I struggle to suspend my disbelief when someone is doing data analysis or hacking on a computer and goes clack, 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 and it just works. No bug, no print statement, not having to turn the computer off and on again, and I just can't believe it.
Yeah. Maggie.
The sound of space. That's one of the problems. Space is a vacuum. So actually, sound wouldn't penetrate through space. And so you see, the shooter box, pew, 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 and you have things taking off and traveling through space, and shh, none of that would be. But I understand, because it seems very unnatural if it was just totally silent. But at the same time...
They should just not let scientists into the cinema. This is my ridiculous gripe, which is niche, even by your standards. It's inconsistent spacesuits in films. So, like Gravity, which don't get me started on Gravity, but Sandra Bullock's suit, now that quite clearly she is wearing a Sokol-Soyuz suit. Well, actually, it might be a Strik, one of the Buran suits, but it's a Russian intravehicular spacesuit. But the helmet's all wrong. That's from an Orlan EVA suit. What?
Good, man.
I can't believe they got that wrong.
Somehow you managed to be the most pedantic of all of us.
So that's the Sokol suit that we wear on Soyuz. And look at the difference. That's the correct helmet. And then if you look at Sandra Bullock's helmet, it's all wrong.
I love 5 years into doing Question Time on Sky at Night, and Dallas has finally got to his pet subject.
I know. Finally, I've got that off my... It's been bugging me since Gravity came out.
Well, you're going to like my answer.
Come on,
I want to critique a well-known science fiction film, Titanic.
Let's have a look. Let's have a look. So what is your
Well, you can see the night sky here, but they didn't consult an astronomer, so you can work out by looking at the night sky where on the planet you are and what time of year it is. So in the original cut of Titanic, as the ship goes down, it is very clearly March, and they're somewhere in the tropics. And so this raises all sorts of questions about who put the iceberg there, how they got that lost. I think this is a very different film.
Icebergs of the Caribbean is a whole new...
Also, I mean, I am the kind of person who sat watching Titanic and this is the star map they should have used. This is the 1912 sky. But I am the kind of person who watched the ship go down and this cinematic description of those people dying and went, the stars are bright.
They're hanging onto a plank.
Were they? I wasn't looking. Yes.
Anyway, thank you very much indeed. That's all we've got time for this year's Question Time special. We do this once a year. We're a bit like the Blue Peter tortoises. What happens after this show is we get packed away in cardboard boxes and straw and put away for a year, and then we come back again. But we've had some incredible questions, so thank you very much to everyone who's submitted a question. Thank you all panellists for your wonderful, amazing answers. Give them a round of applause. Thank you very much. Thank you. Thank you very much to our lovely audience who've come to the University of East London. It's been an absolute pleasure. Thank you, of course, to you at home for tuning in. I hope we've sated some of your curiosity. I hope you've enjoyed the show. It just remains for me to say good night.
New discoveries, natural wonders and strange mysteries all waiting to be discovered. Voyage across the solar system in Brian Cox's new series on BBC iPlayer.